All right, so we're going to spend a thrilling 15 minutes, no, more than that, 50 minutes or so, talking about Android app pen testing, and it's a little bit of an overview talk, okay? We're going to talk about kind of the things it takes to do Android app pen testing, and we're going to do a little bit of demo work as well. All right? First of all, about me, I'm Joff. I didn't bring my hat this week, which I regret, but I did buy some cowboy boots, so I'm feeling pretty good about that. Security researcher, pen tester with Black Hills Information Security. I am also the SEC503 instructor with SANS, which is Automating Information Security with Python. Highly recommend that class. You cannot go wrong by adding Python skills to your tool belt. Definitely a good thing to have. I'm the co-host on Security Weekly once in a while. When I'm home, usually, sometimes I stumble my way into New England and have a good time in the studio. And additionally, I am a musician, geek, and try to be an all-around fun guy. And basically, I try to be nice, especially this day and age to women and family, because it seems like nobody wants to be nice anymore. All right. We also have with us Mr. Derek Banks, who is doing so many talks this year. I think he's like officially the WWHF talk something.
Wait, what talk is this? Was anybody in track one to see? Yeah, thanks for coming back and seeing me. Yeah, I didn't mean to end up being in 2 talks, but just like the previous one, I got to really learn not to follow the SANS instructors for, their bios, because yeah, I got a lot less stuff. I am a pen tester for Black Hills Information Security, security analyst, whatever you want to call it. I am the founder of a CitySec meetup in Tidewater, which, unless the one guy from Norfolk's in here, y'all probably don't even know where I'm talking about, right? Is anybody from Virginia? Oh, yeah. What? Seriously? All right. Okay. And then, as the previous talk didn't say, but I probably mentioned, I'm an avid Office web app enthusiast. If you still run Office web app, I appreciate it.
All right, excellent. Derek has plenty of great creds. Let me tell you, he's an awesome pen tester and a very creative guy. So we have a good time together. We've done a lot of red teams this year. It's been a blast. Okay? All right, let's get going. Agenda. Who the heck cares about Android apps, and why should we? Okay? Testing, environment considerations and tools. We're going to talk about some methodology for testing a little bit, some file system behavior, network behavior, application file stats, that kind of stuff, right? We're going to talk about some example attacks at the end of this session. I'm actually going to do a live demo. Live demo. Please pray to the demo gods for me, where we're going to embed a interpreter APK into a legitimate Android app. So that'll be fun. All right? Why Android? Well, because Apple iOS have these 5 guys in a cave approach. I can't take credit for that, right? That's Josh Wright's statement. 5 guys in a cave mean they try to filter everything that comes into the closed app store, and they pretty successfully manage to avoid malware. Doesn't mean they always avoid malware, but they're fairly successful, right? Android, on the other hand, is wide open, free love society. It's awesome, right? Anybody can publish an app. Also, Android has the majority marketplace, right? There are 2 billion Android users in the world. The open marketplaces are exploitable. They cannot keep up with it, which means, well, fun and games for everybody, right? Microsoft. Does anybody have a Microsoft mobile Windows phone? Oh, well, there's one.
You work for Microsoft.
All right, yeah, okay. If you work for Microsoft, you don't count. Okay. All right, so let's face it, Microsoft lost. It would have been an awesome architecture, to be honest. It really had winning ideas, but open free love tends to work better here in this space, right? So Android wins. Worldwide market share at 80% plus and growing. It's wonderful, right? What else about Android? Well, the operating system split. Thanks to our friends, the telco providers around the world, Android is not up to date everywhere at all. Okay, Android, typically, you're going to see a majority of people running either Lollipop or somewhere between Marshmallow and Nougat, right? But the latest and greatest, the 8.0 stuff, well, that's up on Nougat, and only if you have a Google Pixel 2 or 3. 3's come out now, I think. Anybody? Yeah? All right, or if you have, I just got myself a, what is that? OnePlus 6. I got a OnePlus 6. That's a pretty good phone, too. Okay? And you're going to be running Android 8, but not many people are doing that. Most people are stuck in this space right here, running Lollipop. Okay, Android 6 something. Yes, sir. 9? 9 now. See, listen to me behind me. All right, so this was from July. What are the risks? Enterprise data on Androids. Is there enterprise data on Androids? Do you read mail on your Android? Yes, there is enterprise data on Androids. People use mail as a file system, right? They send all sorts of things around in email. Poorly written apps apparently are still a thing. Of course they are. In fact, we've got some samples we'll talk about later where we've tested some mobile apps, and we found dependency issues in the stack, in the app, where some sort of library dependency or API that the developer has used has some poor functionality remaining in it, like debugging capability, for example, right? Library dependencies with vulnerabilities, yes, that really happens. And why is that silly cursor over that slide? Okay, back again. Malicious apps in the open marketplace, well, I think we just covered that. Okay, sidejacking, re-signing, legitimate apps, and then, of course, you can affect a large number of people. So there's all sorts of fun that can be had here. Before we have some fun, if we're looking at hacking mobile, or if we're looking at reversing mobile apps, if we're looking at doing mobile assessments as pen testers, we need to have for ourselves a suite of tools pre-installed on our platform of choice, and it takes a significant amount of setup to get that right. Okay? We have nice-to-have tools, we have must-to-have tools, and then we have the issue of emulators or hardware devices, plural, that we may need to use as part of our pen testing or reversing exercises that we're going to do, right? We also have the issue of getting a hold of applications, the APK files. Just using the Google Play Store is kind of boring. You actually want the APK package file itself so that you can unzip it, so that you can decompile it, so you can do some interesting things with it, okay? And then side-loading and debugging capability. Here are the must-have tools that we really have to get in place today. JADX, or JADX GUI, is an Android Java DEX decompiler. That allows us to take Android APK files, to decompile them into Smiley, which is the disassembled or the assembler version of the language, if you like, and then subsequently decompile that and reconstruct the actual Java source that the application is written in. Very, very useful. Android Studio itself, plus the emulator AVD that comes along with it. Very useful to have, right? Because you're going to want to be in the position of understanding how to write the Android app a little bit more. You don't have to be a developer, but it's very, very helpful to crank up Android Studio, do some sample code for yourself, and just kind of see how things work, right? Just get a feel for it. You don't have to be a sophisticated developer. You want this little tool, AXML Printer to Jar, which is a Java app to extract an XML manifest that's in binary form in an APK file and turn it back into its text form so that you can then analyze and look at the data inside that manifest file. Okay? We want to have Drozer, which is a way to look at Android internals. Drozer is sort of like a Metasploit equivalent for Android. Not quite, it's got some different features, but it's a command line tool that you can use with your Android systems, be they emulator or hardware devices, while you're analyzing apps. And then you want some devices, because sometimes the emulator is not enough, right? Sometimes the emulators have issues, such as only being x86-based emulators and not being ARM processor-based emulators, and sometimes you truly need the ARM processor on there to run the code, and a device is the easiest way to do that, because otherwise it is ungodly slow to run it as an emulator. I find using a Motorola device, typically the Motorola Nexus A6, I think it was an A6, or the Google Nexus, a very, very nice device to have, because the rootkits to actually root them are very clean. They work just about every time, and you just install them, run them, and you're good to go. And you can pick one of those up on eBay for a relatively inexpensive price these days. You'll probably pay $60, $70 or something along those lines, right? Nice to have tools. Genymotion I found is extremely useful, and when I do the demo today, I'm going to use Genymotion to actually show you an app running in an emulator. Genymotion is faster than the Android Studio emulator, and it uses, I believe, VirtualBox to do the emulation. It's an x86 emulator, and it has a very snappy screen display, and it's very, very manageable and useful way to run Android to test your apps and to reverse them, right? MobSF, Derek's going to talk a little bit more about this. This is an automated mobile app assessment framework for Android, iOS, and Windows. It does dynamic, static, and malware analysis, and frankly, I've never used it, so Derek will actually be able to speak much more authoritatively to MobSF, okay? Now, the first thing you get, once you get set up, you get your studio environment set up. I installed mine in Mac OS X. You can do a Linux environment there, a Windows environment, you choose. Just be aware, though, once you get your Android testing environment set up, then keep it on that platform because there are a lot of moving parts, and you really don't want to move away from the platform that you start with because it takes quite a while to build up the different tool sets, okay? So choose an Android to emulate once you get Studio up and running. I typically are going to use Pixel 2 or some Nexus variety. Choose an OS version. With the OS version, keep the market share in mind. So if most people are running Lollipop or maybe Marshmallow and Nougat, right, they're in that 6 to 7 kind of range, then you probably are better off testing your apps with what the majority of the market is using because that's going to be reflective of what your customer, if you're dealing with a pen testing engagement, of what your customers' users are probably using, right? Because they probably got some provider like a Verizon or AT&T and so forth, right? SSL TLS traffic through a proxy becomes a little bit trickier after 6, but the process is effectively the same. I think everybody in this room is probably aware that there's been a war on SSL and TLS for a while to kind of get us to stop intercepting the traffic. The trick basically is still the same, though. If you can export the certificate from Burp Suite or your other favorite interception proxy, get it into the Android operating system, usually via file, either side-loaded with something like Android Debugger or just directly imported from a browser, and then import that certificate into the root certificate store, and you can SSL man in the middle for the most part. Okay? ADB, already mentioned it. I don't know why, but I seem to have an affliction with Courier font, but that's nothing to do with ADB. Okay? ADB is the Android debugger. Once you get your environment set up, ADB becomes extremely useful because you can interact with the device. You can start a shell on the device. You can push and pull entire portions of the file system from the device. You can actually install APK package files using ADB install onto the device. So command line ADB is extremely useful for you from a starting perspective. Okay, what I find myself doing quite a lot in the beginning of some analysis is to use push and pull. Most Android apps are installed in the /data/com.app app domain reversed, right, kind of form, and that becomes the root directory for the application install. It's very convenient to install an app, pull the entire file system back to maybe your Windows system or your Mac system or your Linux system, whatever you're using for analysis, then run the app, go back and pull it again and do a diff between the file system once you've done that, and you immediately get a picture of what has changed when an app first starts up. That first step of analysis, extremely useful thing to do, right? And then you continue to do that kind of activity whenever you're interacting with the app, such as providing it with credentials or turning on some sort of feature in the app, right? And you can get a sense of what the code's doing from a binary level on the file system. So ADB push and pull are extremely useful in this respect. What about finding the package file itself? This is going to be 1,000 things very quickly, by the way. So we only have 50 minutes, right? Finding the package file itself. Well, the Google Play Store is not going to be good enough, right? It's much easier for us to go out to an APK file mirror site, such as APK Mirror or apkmonk.com, search for the APK that we're looking for, and that's the Android package file. And by the way, an Android package file is just a zipped package of runtime stuff, right? Grab the APK, download it, and then sideload it onto the device or the emulator using ADB install, right? And we can unzip it even in its form as the Android package file itself and investigate the file system, okay? You might get the APK file directly from the customer. That's entirely possible, right? They may have some proprietary code they don't actually want to publish on some of these internet sources. And that's perfectly reasonable. If that's what the situation you're in, you just say, hey, customer, you need to give me the APK file, and then go from there, right? Sideloading. We always use the ADB to sideload. It's as simple as using ADB install. You can put the app on your emulator or any other rooted device. You do want to be rooted. You need to have root access so that you can look at the file system, so that you can manipulate things in the file system. So it's not sufficient just to grab your Android that you're using for your day-to-day production use and stick it on that, because you're going to have to root your Android. Better to get a device from eBay or something like that, root that device, and then sideload it from there. When you're sideloading, basically, if you have a hardware device, what you want to do is just attach it with the USB cable that came with the device, and your computer will just see it as a device that ADB can use. You need to turn on debugging mode in the Android itself, because otherwise ADB won't see it. Okay, so that's one tip. You've got to turn on debugging mode. Then you can use ADB devices to list the device, and then use ADB install to directly install an APK file side-loaded onto that Android. Now, a little bit about Android internals. What's your intention? So there's this concept in the Android Java virtual machine programming environment that is called intents. Intents is a little bit like inter-process communication for other operating systems. Everything you do in the Android is going to involve an intent. When you first click on the app with your finger, you are starting an Android activity. There is an intent delivered to start that activity. If you have a service that is running on the Android, quite often that service involves an intent to start it. What this actually implies is that an intent can be used to transmit messages between apps on the Android. It is not a standalone sandbox kind of situation. And so if the application developer does not appropriately filter the intents in the manifest and within the code, then you have the ability to send apps data, and perhaps send them data that they don't expect. And we all know as pen testers, for those that are, sending data that apps don't expect is a fun thing to do, because most often you're going to see the app crash or probably perform some activity that is fun and exciting for you as a pen tester, and maybe a little less desirable for the developer, right? There's another concept in Android, and that is broadcast listeners. A broadcast listener can receive an intent and act upon it. An example would be turning your Wi-Fi on. There is an intent that is delivered from the system out to all apps that are listening that signal the app that the Wi-Fi has been turned on. And so your app can actually use that broadcast to decide to do something. It's an intention that is allowing the device to make some sort of action. People mess this up. I was going to say the F word, but I'll try not to. People mess this up. They end up defining broadcast services that do things like enable debugging. We found an app fairly recently that we were analyzing. I will not mention the customer, of course, that when we sent it an intent to this broadcast address, it actually enabled debugging and logged every single HTTPS transaction in the ADB log, down to the cookies, all the headers, all of the body of the content, and basically every single thing that was going on with this app. We decided that was fun. We got session cookies, for example. That was pretty cool, right? And the developer didn't even know it. The developer used a library and thought that the developers of this library had properly filtered the input to that broadcast listener. Turns out they had not done so. And by reading the source code, we were able to actually work out what would happen when we send it a specific broadcast message. So, another thing to be aware of, ADB logcat is the command. The ADB logcat command on your platform that you're using for analysis will show you the system log in an Android. Viewing the system log can have very interesting results. You can find out all kinds of weird things, especially if the developers left a lot of debugging statements inside the code. The manifest. The Android manifest is extremely important. The manifest declares just about everything the Android is going to do. In the APK file, and when you decompile an Android application using JADX GUI, you will see an Android manifest.xml file in the decompiled output. If you only unzip the APK file, it will be in binary form. If you have that situation, you need to use that AXML to text or something, I think it was called. I forgot the name of the tool now. Jeez. Anyway, to turn the binary manifest back into a text manifest. Either way, you need to look at this because it declares the app name, it declares all the components of the app, it declares all of the intent declarations for activities, broadcasts, and services, it declares intent filters, it declares all the permissions that the app needs, and it declares the hardware and software features needed. By examining the manifest very early on in your analysis, you can get a really good sense of what's going on in that particular app. Okay? Always look at the manifest. Drozer, I mentioned briefly. Am I past your slide yet? I hope not. Drozer is a framework for Android security assessments. Drozer consists of two different parts. It consists of an agent, which is an APK file, that we run on the Android device, and it consists of a console that's running on some Linux variety. It's usually easier there, but you could run it on Windows, but Windows Defender is going to jump up and down and go, ooh, malware, right? Drozer is not malware, okay? And it communicates on TCP over localhost. Usually we forward port 31415, and once you get the agent running, you can use the Drozer console to connect to the Drozer agent, and then you can start stimulating your app with things like broadcast intents, service start intents, activity intents, and so forth. So you can start basically poking at your app, and you can examine the application's attack surface and a number of other things. Derek's going to dig in on a few of those things, I believe. Okay? To start a Drozer session, we included a little bit of command stuff here. We want to ADB forward TCP 31415, which is the default port. Then we use the command Drozer console connect from the Linux system or the Windows system that we're using as an analysis platform. And then we're often running with a Drozer prompt that we can then can use to stimulate the app with various stimulus response actions. Okay. JADX GUI to decompile and deconstruct the DEX files. Okay. Android runs a Java virtual machine which interprets these DEX files. DEX files can be decompiled into files we call SMALI, S-M-A-L-I. SMALI is essentially assembler code for Android. Okay, so when we decompile into SMALI, we can take it one step further with JADX GUI, which then attempts to reconstruct the Java source code from the SMALI assembler files. Reconstructing the Java source code tends to be very accurate unless the developer has used some sort of obfuscation library or obfuscation API. Then it becomes a lot more difficult. But guess what? Not many developers use obfuscation. So fortunately for us, we can usually see very well what the app is doing. Once you have decompiled it, you can actually search through the source code for interesting things from a pen testing perspective. You can look for intent communication method calls. You can look for dangerous network class usage. You can look for things like the SMS manager that's in use. You can look for a contact and address book access, right? It's quite often the case with malware, particularly, that a malware author will put in an SMS call to text some premium SMS message and send some system information or maybe even pull your entire address book and send it out to some botnet channel, right? So you want to look for those kinds of things. Dangerous network calls. I wrote one of these myself, Android app that fires up and it immediately just opens a back door to some network socket and then dumps a bunch of interesting information across that TCP socket. So if you have TCP socket calls in there that are not typical HTTP API related things, you've probably got a malware-infected app of some kind, right? All right, I'm going to turn this over to Derek now so he can talk a little bit about methodology, and then towards the end of the talk, I'm going to do a brief discussion of actually jacking an app with an interpreter, which is kind of fun. All right, Derek.
Okay, so has anyone here taken the SANS 575 class? Okay, so that class is, what, 6 days long, and they cover iOS and Android. We're trying to cram all this into, what, 45, 50 minutes, so we're going to try and go a little bit fast. So there's the OWASP Mobile Top 10. Those top 10 guidelines are pretty in-depth. We're going to talk about a few of those things. And then also in 575, Josh Wright put out what are called mobile device report cards. I've used both of these as methodologies. They have overlap, but they're kind of approached with different goals. The report cards are more for a kind of a quick picture of an app, whereas the top 10 guidelines go into binary reverse engineering. So we're going to talk about a 47-step pen testing methodology in the next 5. No, I'm kidding. We're not going to talk about that. We're going to talk about a couple of the things that I feel are really important, some of the things that we've seen doing application analysis at Black Hills. So just like any other pen test, you want to start with reconnaissance. Kind of figure out some of the things that Joff was touching on before. All those manual tools are great. I'm lazy. I admit it. I like MobSF. And so some of the things we're going to look for in reconnaissance, after reconnaissance, we're going to look for what's being put on the file system. Some common issues we see are credentials stored in the clear in file system or in a database. And then network communication is very important. And we talked about intercepting TLS earlier. Sometimes we've seen apps that aren't even encrypting their data upstream. So that's, it used to be more common. It still happens. So, I like when I do network capture to also do full packet capture, and we'll talk about that here in just a second, and then also some Drozer steps. So, like I said, I'm lazy. I like using MobSF because it's easy to install if you use the Docker container, and it also offers a REST API if you're in a kind of an environment where you need to integrate it into some kind of life cycle of development. You can integrate it inside. So if you want to find your package once it's installed, here's some ADB commands that you can list packages. You can also do it if you're connected up with Drozer. Here's a screenshot of MobSF. Again, I'm lazy. All those things that Joff was just talking about, if you just use MobSF, it'll do it all in the back end, and then it gives you pretty graphics that you can put in your report and impress executives. This was the Strava application. Is anybody a Strava user? Yeah, me too. So tomorrow I'm doing a campfire talk. He wasn't kidding. I don't know how I ended up in so many talks, but tomorrow I'm doing a campfire talk on some really interesting things that we found with Strava. But if you've ever done any kind of app analysis, 175 activities, holy crap, what are they doing? So here's an actual screenshot of intercepting some network traffic where, just pretend for a moment that this wasn't encrypted. It was actually encrypted, but as you can see, when you intercept with burp, you're going to get the HTTPS communication, including session cookies. And I'm kind of moving fast because we only have about 15 minutes and there's a demo. And you'll find out whether or not the application is doing things like certificate validation, certificate pinning. Those are techniques that developers can use to make sure that you're not intercepting their traffic. So how do you get to the traffic? Well, Joff mentioned Burp Suite. I prefer to use Burp Suite. There are other proxies that you can use, but Burp Suite is pretty much the de facto. I used to be a previous blue team, so I have this affinity for full packet capture. I also like to set up a soft AP. I have a coworker who wrote a blog post on how you'd set up a soft AP and then capture the traffic. And then once you have the PCAP of the application running, you can use things like Wireshark, TCP dump, or Bro. I won't start talking about Bro because we have no time. And here's how you would go on Android 6 to install the certificate. Joff touched on it just a bit ago. Essentially, you generate the certificate with Burp by just visiting in a browser. You'll download the cert DER file and then simply rename it, and then use ADB to push it to the card, and then inside the device or push it to the device to whatever location. I like the Mount SD card download location, and then from there just install it from the settings under security. So one of the most common things that we find is insecure credential storage. And Joff was talking about that trick where you install the app and then you pull off the file structure and then you run a diff, or you pull off the file structure, then you log in and then you pull the file structure again and run a diff. That 5 minutes worth of work has found me clear text credentials in many apps in the past. And this is actually an example of that. If we go back, this app that I know it's kind of hard to see, but that session token for this application where it's TLS traffic where I was intercepting it, that's the same session token. They were storing it in the clear. And you might think that's not quite a big deal, but if you're storing it in the clear, it's possible for an attacker to go after that. So how do you get on the file system? ADB. It just lets you launch a shell, and then you're basically at a Linux prompt. And from there, it's Linux utilities for the win, right? Things like strings, grep, find. Kind of easy things to use, but very powerful once you're looking at the file system itself. So Joff kind of stole my thunder earlier when he was talking about the app that we ended up putting in debug mode. So here's the actual screenshots of that application. Now just pretend like it was your banking app, right? It wasn't a banking app, but if it was, they have an intent listening where I can basically send it a specific command and force it into debug mode and send its HTTP traffic, including session tokens, to the world-readable log file. And they didn't even know. They didn't code it in there. It was part of a library that they were using upstream. And they had no way to fix it. And so when you're banking on your phone, just keep that kind of stuff in mind. And so how did we find that in the first place? So what we did was we used where we decompiled it and just started looking through the code for specific specific terms in the code, sort of get extra, location manager, things that we knew would be kind of sensitive terms where it would kind of lead us in the right direction. And then once we did that, we used Drozer to start the component and give it the appropriate command line arguments to force the app into debug, just like we were another app online. So I mean, theoretically, it would be possible for me to write an Android app, push it up to the Play Store, and broadcast to that intent. And so what do you think the chances would be if I wrote an app that did that, targeting like a banking app, and just sent those session tokens off to my server? Do you think the Google bouncer would find that? And how that's what they call it, right? I mean, out of how many apps are on the Play Store, I think it would be kind of difficult. I mean, because it's not malware, right? It's just me broadcasting to something that's listening and then reading the log file and sending up data. That's benign, right? No, but that's exactly what could happen. And then one of the other important things that we've found, or one of the things that we think are most important in app analysis, is code level quality and tampering. And what we mean by that is basically, well, jacking your app, right? And so how many people in here are Fortnite players? Okay, we got one. Does anybody know what Fortnite, who has kids? You have to know what Fortnite is, right? Okay. Does anybody know what Fortnite is doing? Was it Epic? What they're doing with their APK file? Yeah, they're not going through the Play Store. They're putting out an APK that you then just install. You sideload onto your to your device. In fact, you have to go in and decrease the security of your phone to install that APK. Now, what Joff's getting ready to show you, keep this in mind. I can just send out an email and say, hey, go get your free copy of Fortnite to whoever, and see if you think this might be a good attack, right?
Yeah. Thanks, Derek. So it's really interesting to me to observe, and I just remembered this literally as we're talking, because the Android ecosystem allows us to send intents to any other app. From a malware perspective, it's entirely possible to write a malware app in multiple different pieces. A malware app might even be 20 different APK files that slowly stack up functionality and have a dependency on them so that one file triggers another APK file or another app to do something and eventually leads you to a deep and dark place, right? This is a open play kind of fun system on the inside. So now you're all going to stomp on your Androids and crush them into the ground with your boots, right? Yeah, or go get an iOS device. But we love our Androids. Okay, so now I'm going to tempt the demo gods. But before I do that, I'm going to talk about the steps required to embed malware in an existing legitimate app. Android APK files are typically compiled as Dalvik executables, right? DEX files. There is another tool called the APK tool that allows us to decompile a DEX file into Smiley, which I said before is the assembler-like code of an Android app. Metasploit can generate Dalvik executables for payloads. In other words, Metasploit can generate APK files. We can also decompile the Metasploit APK files into their Smiley equivalents. So what if we decide to take a legitimate app, decompile it with apktool, take Metasploit, decompile it, and then use some assembler tricks to put the assembly code back together, recompile one app with both code functionalities into the same app? It's entirely possible to do so. Now, there are a lot of steps to do this. This is not for the faint of heart. First of all, we need to download the app we're going to jack from APK Monk or APK Mirror, one of those. Then we need to generate our Metasploit file. Probably we're going to generate some sort of C2 channel because it's fun to do so, like a reverse TCP or something like that. Then we're going to use apktool to disassemble both of these APKs into Smiley. We're going to copy the Metasploit staging code into the app that we're jacking up here, or enhancing, right? Then we're going to locate and adjust the main entry point of code. We're going to adjust the privileges because Metasploit requires a lot more privilege than your average Android file, okay? We're going to reassemble the newly edited Smiley code. Then we're going to re-sign the code with our own certificate, and then we're going to upload to an Android system with ADB install and profit. Now, of course, if you have a certificate that entitles you to be a developer, there's nothing to stop you from uploading it to the Google Play Store and profiting also, although that would be a little bit of an evil thing to do. Now, we will have some challenges here. The first challenge we're going to run into is hardware and emulation challenges. Most APK files are going to be compiled for the ARM architecture. I talked about this earlier. When you have ARM, you have a significant problem because your emulators are typically going to be running as x86. The real solution to this is to use either ARM translation libraries like libhoudini, which works fairly well on Genymotion, or to use a USB-attached hardware device, okay? The latter solution, frankly, is easier because then you're pushing all your code to a real ARM processor, and it's just going to work. apktool sometimes has issues with some of the resource files. Resource files are related to things like icons and graphic elements of the app. So sometimes you get into a recompilation issue. Decompiling the APK files is as simple as using apktool, decompile, some sort of output flag for the directory it's going to decompile into, and then the APK files themselves. So this is an example of me decompiling the Metasploit and the cowboy shooting game I'm going to show you in just a minute. Locating the app entry point is a little more difficult. You have to go into the manifest. And inside the manifest, you have to locate where this intent filter is that says android.intent.action_main. And then the Android activity name associated with this is going to be your entry point into the application. In this case, it's com.cowboyshootinggames.mainActivity. Okay? Now, just like a lot of Java projects, once you have decompiled it, the android.intent.action.main, revise that, the com.cowboyshootinggames.mainActivity becomes a directory path underneath the source code where the mainActivity.smiley file will exist, okay? Then you have to modify the mainActivity.smiley file to include a static entry point for the meterpreter stager, because you want the main activity from the app to fire off the Metasploit reverse TCP. The onCreate method in that smiley file is exactly the app entry point you're looking for. Add this invoke static line that looks something like this into the app, and that is the path to the Metasploit stager. Now, there's one other item here that's interesting. Notice how the second directory name in that path looks like a random set of characters. That's because I added a feature in some code I'm about to show you that takes the string Metasploit and turns it into a random directory string so that you can't detect it, or you have less of a chance of detecting the injection in the final APK file. Now, you can do that anywhere along the path. That's a future enhancement, which I'll get to one of these days. And then don't forget, you have to copy all the smiley code from the Metasploit stager over to the APK directory structure, then copy all the permissions and the feature lines from the Android manifest of the meterpreter code into the app that you're jacking. Once you've done that, then you need to reassemble all of the code, and then you need to sign it with a brand new key, and then your final APK file is ready to be sideloaded. Now, who remembered all those steps? Not a one of you, right? There's like 47 billion steps, and you can trip over yourself so easily and get it wrong really, really easily. It sucks. I'll just tell you, it sucks. Well, it turns out that I happen to teach this class called Automating InfoSec with Python for the SANS Institute. So I'm like, screw this. I'm going to actually write a Python script to do this, because I hate having to do these things manually. So on my GitHub, it's Yoda66. There's a thing called Android Embedded. By the way, I'm very proud. I finally got a hacker handle. It took me years to think of that, right? I finally put up Android Embedded. And what Android Embedded does is it automates all these steps. Now, I will warn you, it is a quick and dirty script, and it's worked maybe once or twice. So don't actually shred me on Git when you find out that it doesn't work for you, okay? But do send me constructive feedback if you want to. It decompiles the APK files. It locates the main entry point by intelligently parsing the XML. It doesn't do it in a half-you-know-what way. And then it adjusts the entry point, it adjusts the smiley files, recompiles and resigns, all in one nice command line step. That's so much better, right? So much better. Okay, so let's do a quick demo. What do we got? All right. Demo time. Pray to the demo cards this works. I have a Kali box set up. And the Kali box has a Metasploit handler sitting on it here. Okay? I'm going to see if my Wi-Fi is still up here. And of course it's not. 1 second. Listen to the music in your heads. Okay. Oh, please, Wi-Fi. Oh, please, Wi-Fi. Work. All right. Anybody? Let's see what SSID we're on. Where'd my mouse want to go? We're on the CTF Wi-Fi. It's not working. All right. We're switching to the hotel. Just listen to the music in your heads. You know you have it, right? Demos. All right, here we go. We're on my Kali box, right? In my root file system here, a couple of APK files. All right, I have a pre-generated Metasploit MSF 443.apk. I have a com.cowboy shooting games, which is the one I was talking about in the slides. Here's how you run my tool. Here, hold my beer, Derek. Oh, come on. This is what happens when you run over the hotel Wi-Fi. All right. All right, we're going for the hotspot. Oh, no, here we go. We got it. All right, we're going to try it. It really works as simple as this. It will generate your own key store temporarily during the signing process. So you pass it the APK file that you're going to sign. You pass it the Metasploit APK file that you're also going to embed, and you hit enter. And it really is that simple, and it does all the work for you, okay? So it's going to decompile Cowboy Shooting Games. It's going to decompile the MSF 443. It's going to locate the entry point. It's copying the malware payload over. It's adjusting the manifest. It's compiling. Well, can you feel the tension? And it's going to sign the result if the Wi-Fi continues to work. And it's going to place the result in the .ae directory as final.apk. Now I'm going to resume my screen session, which is my Metasploit session. Okay, the multi-handler is already set up. In this case, come on, Wi-Fi. Come on, you can do it, Wi-Fi. In this case, it's the Android Meterpreter reverse TCP, okay? I'm going to go over to Genymotion, where I've already preloaded the final.apk as Cowboy Shooting Game here. And I'm going to run it. And I can play Cowboy Shooting Games, but I have a Meterpreter session. All right? Thank you, thank you. And we can, now Meterpreter's fairly full-featured. We can do things like, oh, I don't know, dump the contacts, right? Well, there isn't any contacts in this one because it's just an interpreter. I mean, just an emulator. But you can use my tool to attempt to decompile any of the APK files you find online and see how it goes for you. Like I said, it's only worked once or twice. I wrote this script in 10 minutes, all right? But I'd love to get your feedback, and I'd love to be able to improve it beyond just Metasploit stuff to any kind of APKs we want to put together and do a little bit more work on it, all right? All right. So you can get that at the GitHub. What about practicing your skills? Derek, I think you're going to talk a little bit about this.
So once again, that's why you don't want to not use the Play Store. I mean, think what you will about Google or not. It doesn't matter. The Play Store actually is useful for trying to prevent things like this. Now, would this work with a flagship APK file from a large developer? I don't know. I bet given enough time it would, right? Enough time, you probably hack it, right? So to practice, there is an app called Damn Insecure Vulnerable App that was written by, apktool. I'm not really sure. If you go and get it from there, there's a couple of things you have to do to get it compiled. I have a fixed version. If you're interested, I can give you the APK, or just I have it on my GitHub forked as well. And then if you practice with that app, all those things that we talked about are in that app, short of some of the network stuff. Let's see, is it next?
Oh, sorry, man.
That's okay. I think now I'm not in frame of the camera, too. So that's pretty much it. I think we're pretty much out of time.
Yeah, let me get the next one. There you go. So if you want to get our contact info, the QR code here is not a social engineering experiment.
Scan it. It's fine.
Totally scan it, trust me. Okay, that's just going to give you Derek and my name, an email address, our Twitter handles, as well as the GitHub repo, okay? Go have a little bit of fun with it. Additionally, on the GitHub repo, the PDF copy of these slides is up there. So grab those if you want to review them, because I know we went over a ton of stuff in a small amount of time, all right? Thanks, everybody. Any questions for us? All right. Have fun for the rest of the week. It's a great, great week of weather here in Black Hills. Thank you.